Hey there, welcome back. Today we're going to continue on with YoshiStat. This is episode 7. So we're building a smart thermostat. This one is based on C#. We're using the YoshiPi. Got this hardware here. It is basically just a Raspberry Pi Zero with a display, some relays, some things like that. You could build this with just a standard Raspberry Pi or a Pi Zero, but I'm using this because it's got a lot of the hardware that we want for prototyping. Last week we worked on getting settings in, so we did the set point, and the deadband allowed you to adjust the actual temperature that you're trying to drive to on the thermostat. This week I want to go into getting persistence to things. So right now you can set the target temperature for your thermostat, but if you lose power and it comes back up, you're going to lose that. We also need to add some things like the units that we're working with, whether we're working with imperial or metric. We can also adjust, say, if you want a 24-hour clock or a 12-hour clock. In fact, I don't even think we've wired up the clock on the display yet, so we could do that. We could also add in some abilities for time itself. Right now, I don't think we're even pulling time from an NTP server. We're assuming that the OS is going to do that, but we could go ahead and make sure all of that's working. Basically today, let's just work on getting settings persisted, and we'll see what comes up as we work along that needs to get done. All right, so here is our main controller. And in the controller, the very first thing we do is we bring up the settings service. That is based on this interface, and we probably have the implementation here in core. The hope is that it would be the exact same on both platforms. We might have some differences like paths or something like that, but generally speaking, the settings and storage, we want to be the same. So we're going to initialize this. Right now it comes up at 66 Fahrenheit, so we want to actually do some sort of storage on this. So let's just create a settings object that will have all of this that we can serialize and deserialize for our settings. So in here, we know we have a current set point, and it is a temperature. Question is, do we really want to be serializing out a temperature? I guess it doesn't hurt to do so. It's fairly simple. It is a struct. So if we go take a look at what a temperature looks like, it has a lot of stuff in it, but it's mostly conversions. If we serialize one of those, so let's just do a temperature, and I'm going to serialize it and deserialize it and see how that works out for us. And then in the settings service, I'm going to put a load and a save method that allows us to obviously load and save these settings. Okay, so I just updated all of the existing setting service stuff for the set point to, instead of using a local copy of just a variable, we're going to use a local copy of the settings themselves and use that, and we'll do our load on initialize and save down here when we set the set point. So loading, let's just pull this from a file. And to make this cross-platform, we will use some of the built-in .NET stuff for directories. So now we could use the environment current directory. That's tempting. The reason that I'm hesitant on using current directory is it's not always the directory that the app is running in. If you execute it from something else, and I'm thinking like if it's a daemon where we set it up to automatically start when we run, which we likely will do that, then we have to make sure that the daemon is launched with a current directory set to this. If it's not, then we're going to have problems. So we could also do something like get executing assembly, or the entry assembly. In fact, let's do that. We could do get entry assembly location. So this gives us the location of the executable itself. So I think that this is a little bit more reliable than the current directory just because we might be launching from something else. So I'm actually going to use that. And we'll do that only one time up here. I'm going to add a default settings up here. Okay, so it's going to try to deserialize. If deserializing returns nothing, then we'll return a default, or if it has an error trying to do so, we'll just use the default. Saving, we will pretty much do this, the inverse of this. Now this is obviously going to throw initially because the file doesn't exist and it's going to be empty. Now, the exception will handle that and just go to a default, but since we know that that can happen, we should at least be nice and handle all of that. So if it doesn't exist, we're just going to grab some default settings and save it out to the file. We could probably do the same thing if this JSON is empty. So if for some reason there's a file there, but it's empty. But the reality is that will happen here. It just won't get saved. I'm worrying about the edge cases right now. And I probably shouldn't be. We're just trying to drive this forward and get it working. If an edge case happens, we're going to handle it anyway in this exception handler. So we're good enough. Let's put a breakpoint in here and let's just run this on the desktop. So this is another example of why I always, or nearly always, anytime I have a project that has any complexity at all, create both a platform and a desktop version of the app. It lets you test it locally and iterate just so much faster. Trying to run this against the Raspberry Pi remotely just to test whether or not this is working is, even in the best cases, it's slow and painful. I don't like having to do it. I would have to actually get out the hardware and set it up. Right now, I don't even have the hardware plugged in. So we are coming up. Now, if we initialize, I'm going to go in and load. The file doesn't exist, so we're going to grab some default settings, which gives us a set point of 66 Fahrenheit, which is what we want. Now let's go save. Turn this into JSON. What does that look like? This is what I thought would happen, and I would say that this is a little sus on the part of Meadow units. So you can see it's giving us Celsius, Fahrenheit, and Kelvin. Really, when we serialize this, we only need the Celsius. So if we come back and look at what this temperature has, the way all of these units work is they have a base value. So it's got this internal value, and that is some sort of I guess we could call it a root unit. In the case of temperature, it's Celsius. So it is the canonical value in the canonical unit for whatever that type is. Temperature, it's Celsius. So we store this value, and then all of the other things that come out of it, you can see Celsius just returns that, but Fahrenheit and Kelvin, it does a conversion for. It's a read-only, read-only, and read-only. So it's not going to deserialize at all. This will probably come back as all zeros. Yep. So Celsius of 0. So that is not going to be helpful. We cannot serialize and deserialize like that. So again, that's going to be a problem for a different day. What I'm going to do is I'm going to open an issue over in the Meadow issues repo so that we can look at that. But for now, we're just going to do this. we're going to do the set point, and I'm going to set it, store it in here as a canonical value. I'm going to use Fahrenheit. Obviously, you could use that as Celsius if you wanted. Doesn't really matter. But, so now we've got to fix all of the errors that this brings in. File does not exist, creates it, saves it. The default, that's fine. Now let's stop it and let's load it again and see if we end up with what we're expecting. File exists, it loads it. Our JSON has it as 66, which is what we want. And let's just run it. Let's bring our thermostat over and let's go over to our settings. Okay, so we can see that our set point is what we're expecting. Now we want to persist changes. So I think we already have that driving through. I'm going to put a breakpoint right here. And I'm going to change this to, say, 68. Apply that. That comes in. It is not different. It's going to change that to 68. Save it. And then invoke the event. So now if I shut down the app and I restart the app, we could take a look here. It says it's 68 in the JSON, but let's just pull this up. I click here, it's 68. Okay, so that is saving and doing what we want it to do. I've already gotten everything done that I really wanted to today, so let's continue on. We've got plenty of time left. Let's add some additional features. Let's get this clock working. It seems like it might be a little bit of overkill to have an entire service for this, but I think it makes sense for time to be handled by a central location. So we'll do that now. I could follow the practice that I've been and create an interface for it. It's going to be in core. It probably isn't going to be any different on the desktop. I'm going to just use it as a service, as a concrete class. I'm not going to create an interface right now. If we end up changing it so that I have to have different implementations on different platforms, we can add in the interface at that point. Now, generally speaking, time, anytime I'm working with times on a device where I'm storing, getting, reading, pushing to the cloud, anything like that, I do it in UTC time, never in local time. The only time that you would apply a time zone offset is when you're going to the display itself. If you just always deal with everything as a UTC time and do the conversion at the very, very end, when you go to the display, you're going to save yourself a whole ton of headache. So we're going to have a couple of things. I'm going to have the time service. We're going to have a get local time that shows the time on the display. And in fact, we could do a formatting here. So we could get a formatted local time to show it on the display. We're going to come over here and we're going to create the time service. And I'm going to pass that into our display service. So I've now plumbed the creation of the time service here in the initialize of the main controller. So we create it and then we pass it into the display service, and the display service stores that in a local field. So now we have somewhere where we must be showing time. Time label, that's what we want. We have update time. So here is going to be our time service get formatted local time. So you can see it gets set to 11:11 here and then just never gets used. So what I want to do is after everything loads, we load all of our screens, we want to update that label, but then we need it to happen periodically. That's going to set the time label every time we go to the home screen. So when it first comes up from the splash, that's the important one right now, then it would update it if we go like to settings and come back, or go to the set point and come back. But otherwise it's not going to change. So we're going to have to deal with having some sort of a timer in the background that ticks that periodically changes that. But first, let's just make sure that it actually works, that the time does not end up 11:11 on the display. So it comes up 9:27 a.m., which is exactly what we want, and it's in the AM/PM format. Let's deal with that timer right now. Might be a little bit strange, but what I'm going to do is in the control loop, I'm just going to keep track of what minute that we're currently in, and when that minute changes, we're going to tell the display service to update its time. So let's take a look at what I mean here. I'm going to initialize this to a -1. Then inside of our control loop, we're going to wait. And then after we wait, we're going to go look at the current minute. I'm going to look at the date time offset. The reason I'm using date time offset instead of date time is it strips away a bunch of potential looking for things like time zone and a bunch of other garbage. We just need to know what the time is now. The reality is it's probably irrelevant. We're only doing this once a second. It's not time critical, but it's just best practice. So I'm going to look at the UTC now, and then I'm going to look at the minute. So I know that our current minute is this. And if the current minute is not equal to the last minute, we're going to store it. Last minute is current minute. And we're going to do a display service update current time, or update time. Got to try to remember. Okay, we got to go back to the display service. Find that. It's update time, but my guess is that that is not in the interface. Let me change that. Update time. Yep, it's not in the interface. So we'll put that there. And then we have to go back to the display service and to the interface. Just add this in. All right. So now our main controller, we're going to have this control loop, which is happening once a second. And at the beginning of the control loop, it's going to take a look at the current time, the minute. We're going to compare it with this last minute that I've stored. And if the minute has changed, we're going to tell the display service to update. We move this up to the top where it belongs. And let's just run this. Okay, so it says 9:32. I'm just going to sit here until 9:33, and we'll make sure that this updates without me doing anything. Yep, there we go. It has changed. So that is now working. So now let's add the ability to change this time from this format to a 24-hour clock. So let's come back to the settings. We're just going to mimic these, but for time change, right? Now the question is, what are we going to save? Are we going to save a Boolean that says it is 24-hour or it is 12-hour, or are we going to create an enumeration that is the time format? Just to make things nice and clear. Even on something simple, you should use, some kind of best practices to keep yourself in the habit of doing things correctly. So now we can do this, and we'll do the clock format changed. change that to time format so that it matches the enumeration. So the settings service down here, we're going to need both of these. And I also need that event. We'll default to a 12-hour clock. Actually, I'm going to default to a 24 because that's what I prefer. Okay, so we've implemented our get and our set and the event. So now the only thing left to do is to use that format. And I think we had that in the time service. So now the time service needs to know what that setting is. So we can just keep this saved here, private. And so now this will be dependent on our time. This is the 12-hour clock. Otherwise, we will return that. Micro layout, which is what I'm using to display all this user interface. So let's go over and work on the settings screen. We're going to put a label right here that says what our current clock format is. And then we'll have a button over here that just toggles that format. Now we know that we need a label and a button. This time format label, the top of it is going to be just below this. And its width, we're going to make we know our screen is 320. So let's make it, I don't know, 250. And we'll use the setting items font. We're going to set some text into it for right now. That doesn't really matter what I put here because we're going to read the settings and then change it based on that. But I want at least something so that we can test the layout. And then the format button is a new button. Now its left is going to be, let's say that the button itself is 30 pixels wide. So let's go. We're going to go. It will be, its left will be the layout right minus 35. So 30 and then the 5 for a margin. We're going to put its top same spot as here. Its width is going to be 30 and its height is going to be 30. Now, ideally what this would be is something like a button with a little, you know, toggle icon or something along those lines. I'm just going to put some sort of text in there. Something like that might be interesting, but it's only 30 wide. Let's just start here. So we have our format label and our button. Now we need to add those onto the screen. All right, so we put those into the layout. Let's just see how all of these changes look. All right, so it's now got this gradient background. We've updated the settings title. It's bigger. The clock format is here. And we have this button here, which is clickable. Now we need to plumb in the click handler for the button that will change the settings. When it changes, we need to change this text, and it needs to change the clock when we go back to the main screen. So first, let's handle this button click. And we have our setting service in here. So we know that in this, so let's make that label what we want it to be. Hold on a second. This will make sense in just a moment. I'm going to do a generic method here to update all of the settings labels, even though we only have one. In the event that we have multiples, we can do that, right? So time format label text is going to be settings get current time format. And if it's a 12-hour, after it loads all of the app settings screen, that'll seed it with its initial, and then when it clicks, we're going to get the current format. And then we're going to change it. And we're just going to do this. So if it's a 12-hour, we're going to make it time format. If it's 12, we go to 24. Otherwise, we go to 12. And that should cascade through. It's going to raise an event when it happened, though nothing is listening for that event right now. So we're just going to set that, and then, in fact, now we could have updated the settings labels right here after we click the button. But what I wanted to do is I wanted to go all the way around trip back through the settings service. It makes sure that we don't update the label until it actually changes it in the settings that get saved. It also will allow, in the event that that setting gets set somewhere else, it will update this screen. And you might wonder what that somewhere else might be. What if we attach this to like a cloud service or a Bluetooth service or something like that? And then we can set that clock from somewhere else. It will update this settings label live, even if you're looking at it. So let's do it that way. It's on a 24-hour. And in fact, it's interesting. I've got the apply and cancel, but if I change this, it changes it immediately. It doesn't do apply or a cancel. So we could actually change this to just an OK to go back to the previous screen. These are just live changes. So it's a 12-hour and then 24-hour. Now, if I go back to my home screen, so we're at a, and this could just be an OK, we're at a 24-hour clock, right? 24-hour, 12-hour. So we have our clock doing its thing. Let's go over to the settings. I'm going to change that button since we don't have an apply and a cancel. So we're at our 12-hour clock. Change it to a 24-hour. And there we go. Okay, so we've got our settings. We've got our ability to toggle this setting. We have it showing the time. We can click here. I can change my set point. So we want a 12-hour clock and a set point at, let's make it 70 so that it's obvious. Okay, so we have a set point at 70 and we have a 12-hour clock. We'll shut down the app, rerun it. It's a 12-hour clock. It shows it as a 12-hour clock. And our set point's at 70. Okay, so we are saving successfully as well. So there we go. I think that's enough for today. We've made some solid progress. Really, this is becoming close to a functional application. I think we could probably go ahead and build hardware and install it and use this to drive an HVAC. Next week, actually next week I'm going to be out, but the following week, maybe we'll start looking at hardware. We've got a few challenges coming up, things like how do we power this from a thermostat wire. Maybe we could start thinking about how we're going to mount this thing on the wall. Again, we're using the YoshiStat or the YoshiPi as our hardware for prototyping, but we'd like to at least something that we can mount and drive all of this. So we've got a few things left to do. We need to figure out the electronics to make sure that we're powered, battery backup, whatever, something along those lines. We also need to do an enclosure so that we can mount it. And I've got some other ideas. We've got a lot of things that we can add. We could add some Bluetooth stuff. We could add some cloud stuff. We could add a sensor for like motion or light so that it only shows the display when somebody walks up to it. There's a ton of things we could do with this. If you have any suggestions or desires, go ahead and leave a comment down below. Otherwise, again, that'll do it for today. Thanks for watching.